So we're going to continue on with our discussion of the mono class. This is the last section on that. At that point, you should have everything you need to do for the next programming assignment, which will be coming out shortly. Here we'll be talking about key concurrency and scheduler operators that are defined in the mono class. If you recall before, we talked about schedulers.single, which had a single background thread. Now we're going to have schedulers.parallel, which, as the name implies, is going to have a way to run the other operators in a flux stream or a mono stream in a designated thread or in a thread pool. So the parallel operator returns a scheduler that hosts a fixed pool of single-threaded executor service-based workers that is suitable for parallel computation. As you can see here, it's a very simple method. It just returns a scheduler. And basically what we use it to do is to allow for computations to run in a pool of threads. So you can see here we have a method called multiply async, which we'll take a closer look at when we get into our case study walkthrough shortly. And you can see it goes ahead and will take two big fraction parameters and arrange to run them in a background thread. So we use subscribe on to say run this thing in a background thread, and we give it the schedulers.parallel scheduler, which says run this in a pool of threads. And we're going to go ahead and multiply those two big fractions together in some thread in the pool of threads. Now, it might not be apparently obvious from this simple example why this would be useful, why we're running in a parallel pool as opposed to a single-threaded pool, because we're just doing one multiplication. But wait just a moment, and I'll show you how this typically gets combined in practice to actually do something useful in a parallel pool of threads. This particular pool of threads is optimized for fast-running, non-blocking operations. In other words, computation-intensive processing, not I/O-intensive processing. And the reason why it's not really good for I/O-intensive processing is because it's a fixed pool of threads, which means it doesn't grow. If you recall, when you have I/O-intensive threads, like we've talked about earlier when we talked about things like the common fork join pool and how it could be used with managed blockers to expand itself, that's where you need to be able to have a way of growing threads, and I/O-bound threads are well suited for that because they need to block, or they will block, and you need to expand the pool. So fixed size doesn't really work well for I/O-bound threads. Internally, these threads are implemented as daemon threads, which means that the app won't be prevented from exiting even if its work isn't done, even if there's still processing going on. This is important to remember because there's some ways of creating threads using different kinds of schedulers in Project Reactor where you are not creating daemon threads, and therefore you have to shut down the pool explicitly. Now, this particular operator, the parallel operator, is very commonly used with something called the flat map concurrency idiom. Now, we haven't really talked much about fluxes here, so what I'm doing here is giving you a little bit of preview of things to come, but a flux, remember, is just a stream of values. And what we're going to do here in this simple example, which we'll look at later, is we're going to go ahead and take a big fractions list, and we're going to turn that into a stream of flux big fractions. And then we're going to apply this flat map method, which is a bit like the flat map method you are accustomed from Java parallel streams, with a few little tweaks that make it more useful. Because remember, Java parallel streams flat map isn't very useful in a parallel programming context, but in Project Reactor and RxJava, it is very useful in a parallel programming context. So what we're going to do here is we're going to go ahead and say for each of the big fractions in the flux stream of big fractions, we're going to go ahead and run the code that I show here in red. So we're going to use mono.fromCallable, which is just going to basically take that big fraction and arrange to run it in some thread in the pool of threads that comes from scheduler.parallel. And then that will be used to multiply that big fraction by some constant or whatever. So each of those calls is going to run in a background thread coming out of that pool. So this is basically the code, kind of like the code we looked at before, but all these computations here will run in a thread in the pool of threads that's identified by the parallel factor method, and we're going to have a bunch of those things running concurrently, so they're going to be multiplying many big fraction objects concurrently. That's kind of what's going on there. There's a computation method in RxJava's schedulers utility class that works pretty much the same way. So that's a quick overview of key concurrency and scheduler operators that are used with Mono. This isn't actually, in this case, it's not really part of the Mono class, and that's by design, but it's part of what you use with the Mono class.